So for part A, we need the average acceleration. An average acceleration will be the integral divided by the interval of where we are interested. So the average acceleration will be from 2 to 8 at d of t all over 8 minus 2, and that will turn into v of 8 minus v of 2 divided by 6. So we find our values from the table we are given, and v of 2 will be 100 while v of 8 is negative 120. So we end up with negative 220 over 6, which is simplified to negative 110 over 3 meters per minute squared.
Okay, so for part B, it is asking if the table supports the conclusion that the train's velocity is negative 100 meters per minute at a time between 5 and 8. So V8 is differentiable, so that means that the velocity is continuous. And we know this because at v of 8, it is negative 120, and at v of 5, the velocity is 40. So we know at some point in between it passed through negative 100. And this is because of the intermediate value theorem, so it shows that there is a time in between 5 and 8 that the velocity is negative 100.
So for part C, we want to figure out where the train is at t equals 12. So if a of t is the position of A at the specific time, we know that a of 12 is equal to a of 2 plus the integral from 2 to 12 of the velocity. So now we approximate using trap sum. We were told that it starts at 300, so we add 1/2 and the difference between 2 and 5, which is 3, times the sum of 140, plus 1/2 times the difference of 5 and 8, times negative 80, plus 1/2 times the difference of 8 and 12, times negative 270. Everything added should equal negative 450. And when added to 300, the answer would be negative 150.
Okay, so for part D, we have a train that is moving to the right, and we have another train that is moving up to the north, and that gives us a right triangle, and we're looking for the rate of change of the distance between the two. So we will be using the Pythagorean theorem to find that out, which is x squared plus y squared equals z squared. Next, we'll find the derivative of that equation and plug the values in. We'll get 2 times 300, which is a value that was given to us, times 100, which we got from the table, plus 2 times 400, another value that we had, times we had to find v sub b of 2. We were given that equation in the question. Answer for that is 125, so we'll multiply that in to equal 2 times z. Next, we need to find z, and we can do this with the Pythagorean theorem equation that was given to us. So we'd have 300 squared plus 400 squared equals z squared. We would get z equals 500. Next, we'd have to multiply it all out, and we would get dz over dt to equal 80,000 over 500, which gives us 160 meters per minute.